This is section 2.5, which is finding the zeros of polynomials. This is also connected to AP Standard 1.5, which is polynomial functions and complex zeros. So the fundamental theorem of algebra says that if we have an n-degree polynomial, we're going to have n zeros. Those zeros could be real, they could be complex, they could be irrational, they could be rational. So we're going to talk about today how to find all the zeros. So our rational zero theorem is going to give us a list of possible rational zeros. So what I refer to as our P over Q list is giving us the positive and negative factors of the constant, and Q is going to be the positive and negative factors of the leading coefficient. So what this does is it gives us a list that helps us narrow down what our zeros could be. So this was helpful back in the old days before calculators. We're going to use a combination of this and our calculator to help us narrow down and find all the zeros. So this is kind of the list, the process of what I would like you to go through with these problems. So we're going to find all zeros. First, we're going to make our P over Q list. Second, we're going to graph it on the calculator. Third, we're going to use synthetic division to verify our zeros that we see from the calculator, and also we want to get down to at least a quadratic, so then we can use step 4, quadratic formula, we can factor, or we could solve to find the remaining zeros. So here's our first example. We're going to ignore the graph for a second because just to speed up the process, I graphed it for us. So our step 1 that we're going to do is to make that P over Q list. So on this one, our p-value is our constant, which is 8. So we think of all of our factors of 8. So we could do 1 and 8, 2 and 4. So I'm going to put all of those. I like to put them in order. You don't have to put them in order, but we have 1 and 8, 2 and 4. Those are our factors of 8. And then our q is 2. So we think about what are our factors of 2. So that would be 1 and 2. Okay. On some of these, you're going to get a really long list and you don't need to divide them all out. But for this problem, I want to show you what I would get my possible rational zeros. So if I take 1 over 1, I get 1. 1 over 2, I get 1/2. 2 over 1, I get 2. 2 over 2 is 1, which is already in my list, so I don't need to write it again. 4 over 1 is 4. 4 over 2 is 2, already in my list. 8 over 1 is 8. And 8 over 2 is 4, which is already in my list. So these are my possible rational zeros, which means that if we have a zero that's rational, it's going to be on that list. Okay, so that's step 1. Step 2 is we're going to graph it. So I saved us the time and I already graphed it over here. So what we're looking for on our graph is we're looking in combination with our P over Q list and our graph, where does it look like it's crossing the x-axis? Well, I see clearly 4. So from the graph, I would write down that I see the number 4. Now, the fractions or decimals are going to get a little trickier. So I know in my list, my P over Q list, I could have a rational zero that's at positive 1/2 or negative 1/2. And so if I look, I don't have one on the graph at positive 1/2, but it does look right there like I could have one at negative 1/2. So I'm going to write that down as a possibility. Now, I know that this 0 and this 0 are not in my list because if it was like 1.5, that would be 3 over 2. Well, 3 over 2 is not in my P over Q list. If it was negative 1/2, that would be, so the only fraction I have is positive and negative 1/2. So that's why I'm just zeroing in on looking at those areas. Okay, so that was step 2. Step 3 is we're going to do synthetic division. So we're going to set up our original function. So we have 2, -7, -8, 14, and 8. And this time, instead of using what makes the factor equal to 0, we're actually using the 0. So we don't have to change the sign. So I'm going to start with 4, and I'm going to put 4 there, and then we're going to do our synthetic division. So this would be 2. 2 times 4 is 8. -7 plus 8 is 1. 1 times 4 is 4. -8 plus 4 is -4. -4 times 4 is -16. This would give me -2, -8, and we get 0. So that means yes, 4 is a 0 and it works. Okay, now rather than start back over again, the whole point is to get this reduced. I'm going to draw a synthetic division off of that result, and I'm going to do it again, but this time with -1/2. So we're going to drop down the 2. 2 times -1/2 is -1. I get 0. That would be 0. -4 times -1/2 is +2, and we get another 0. So what we just did is we verified that both 4 and -1/2 are in fact zeros of our polynomial. Now we know we have two others. We have that one there and that one there. So we have our option now. We can do quadratic formula, we can factor, we can solve to find the remaining zeros. So what I have right now is I have 2x squared, I don't have an x term, and I have -4. And we're trying to solve where is that equal to 0. So I would look at this and I would say, okay, I could do the quadratic formula. That's going to be a lot of extra unnecessary steps. Since I don't have an x term, I can just solve this. I can add 4 to both sides. I can divide by 2. So that's going to give me x squared equals 2. So then if I'm taking the square root of both sides, I know I'm going to have a positive and negative square root of 2. So that is why those numbers, so if I took the square root of 2 on a calculator, I'm going to get 1 point something and -1 point something. And so those numbers were irrational. That's why they were not on our rational zero list, but they are still zeros. So all of my zeros together are 4, -1/2, square root of 2, and negative square root of 2. Again, I know there should be 4 zeros because this is a 4th degree polynomial. So that's where I should start at the beginning, identifying how many zeros I have. Okay, let's look at our next example. So same thing, we're going to go through the same process. This one is also a 4th degree polynomial, so that tells me I should have 4 zeros again. So we're going to start with our P over Q list. This time it's 80. There's a lot of numbers that multiply to 80. I'm not going to do this one in order. I'm going to go 1 and 80, 2 and 40, 4 and 20, 5 and 16. And there might be more, but let's start with that for our list. And then our Q value is going to be our leading coefficient, which is just 1. So I'm not going to rewrite all of these out because if I divide all those numbers by 1, I get those numbers. So I just like to have the P over Q list because what this tells me is I can't have any fractions as a rational zero. They're all going to be positive or negative whole numbers. So if I look at my graph over here, I see -4 and I see 2. So from the graph, it looks like -4 and +2. So we're going to use those two to verify with synthetic division, just like we did before. So let's set up our synthetic division, our coefficients. We have 1, -4, -10, 68, and -80. So I'm going to start with -4. So 1 times -4 is -4, so it'll be -8. -8 times -4 would be 32. If I add these, I get 22. 22 times -4 is -88. That's going to give me -20. And then this would be +80. So that works. So -4 is a 0. And I'm going to do that again, but this time with 2. So 1 times 2, -6. -12. 10 times 2 is 20, and we get 0. Okay, so both of those worked, and now I'm left with x squared minus 6x plus 10. Now, our options, when we get down to a quadratic, we can factor, quadratic formula, or solve. This one, unlike the last one, has an x term, so I can't just solve like I did on the previous problem. I don't think I can factor this because based on my graph, it was only going through two numbers. So that tells me that it's probably going to be complex, imaginary zeros. So I'm going to use the quadratic formula. on this one. So I know that my A is 1, my B is -6, and my C value is 10. So remembering the quadratic formula, we're going to do x equals -b. So in this case, it'd be -6 plus or minus the square root of -6 squared minus 4 times 1 times 10 all over 2 times 1. So if I reduce this, I get 6 plus or minus, if I take that underneath the square root, I get -4 over 2. Now I know that I can't take the square root of a -4 on my calculator, but I do know the square root of 4 is 2, and I know the square root of -1 is I. So this is going to give me 6 plus or minus 2i over 2, which reduces to 3 plus or minus I. So that tells me that my zeros, let's write down our list of zeros. My zeros are -4, 2, 3 plus I, and 3 minus I. So those are my 4 zeros, because again, it's a 4th degree polynomial and I should have 4. Now this little note at the bottom says that complex zeros or irrational zeros must have a conjugate as a 0 too. So you'll notice that we don't just have one imaginary number, that's not possible. So we had the 3 plus I and the 3 minus I, which are complex conjugates. On our previous problem, we had the positive square root of 2 and the negative square root of 2, which those are they're conjugates of irrational numbers. So just something to keep in mind when you're finding all of those zeros. Okay, so that is it.